Hello and welcome to the video where we talk about actual stoichiometric calculations using that molar ratio that we talked about in the last video. A fair warning, I am at the park, so if you hear children screaming in the background, I promise I have nothing to do with it. All right, so I can't move my screen. Oh, there we go. Okay, so there's the notes that we did in the last video, and we're just going to pick up right where we left off. So recall that the molar ratio is the thing that allows us to convert from moles of one substance to moles of a second substance. So we can actually convert these units not just from grams of one thing, but to, molecules of a completely different thing. And all of this comes from the balanced chemical equation. So you cannot do stoic without a balanced chemical equation. So take a second, read this question, and see if you can write the balanced equation from it. Go ahead and pause the video and then replay it when you think you have the answer. Okay, so hopefully you pause the video. I'm just going to quick write this out and show you what I got. It's definitely a double replacement reaction because we have two ionic compounds. I know that one of the products for sure is barium hydroxide because it gives it to me, but I also can just look at the reactants and know. Then symbols charges crisscross, and we have also Na2SO4, right? BaOH, Na2, yep, okay. And then we balance it, of course, and I'm just going to put a 2 right here, and everything else is going to be a 1. If you have questions about how I did that, then you can go visit the reaction chemistry videos. Okay, so we start this just like we would any other mole problem. We identify what the question gives us, and that's going to be, in this case, 8.72 moles of NaOH, and we identify what the question wants us to get. Where do we want to be in the end? And for this question, it's moles of barium hydroxide. So those are the two most important things, and we start with what we know. So I'm just going to write down 8.72 moles of NaOH, and I'll draw my chart. And now the easiest thing to do is just pay attention to the units. Don't worry about the numbers yet. So if I'm looking at the units, thinking back to the mole unit, if I have moles of NaOH right here, then I know for certain 100% moles of NaOH has to go down here. They have to match. Why? Because they have to cancel out, right? And in order to cancel out, we need those units to match. So I'm just going to put MOL of NaOH. And that's what has to go there, regardless of, anything else. And when I'm at mole, I'm at the magical bridge. I'm at the magical bridge that can pass me from one substance to another. And in this case, it's going to pass me from NaOH, which is, what I started with. That's what's right here, to BaOH, which is what the question wants. So this is my magical mole bridge, and I'm going to cross it, and I'm going to get to what I want, which is moles of barium hydroxide. Okay, so now the next question that you should be asking is, all right, what numbers go here? And again, looking up at what we just said, where does that molar ratio come from? It comes from the balanced chemical equation, specifically the coefficients in that balanced chemical equation. So if I'm looking at, what color should I do here? I don't know. Great. So if I'm looking at NaOH, the coefficient of NaOH is 2, and that's what's going to go right here, a 2. So 2 moles of NaOH for every, again, it's a ratio. It's like a 2 to, whatever ratio. If we're talking about BaOH, then it's a 2 to 1. A 2, like TWO, 2 TO, 1. And it can be written like that. So it's a 2 to 1 ratio of sodium hydroxide to barium hydroxide moles. And then from there, we just plug it into our calculator and get an answer. And I don't have a calculator right now, but whatever 8.72 divided by 2 is, and that's what we would get as our answer, and it would be moles of BaOH, barium hydroxide. And that's it. Let's do one more question together just so you guys have an idea of what to do. Again, we are given 3.81 moles of oxygen And the question wants moles of carbon dioxide. Anytime you see you're starting with something that's different than what's given, you know it's stoic, and you know you have to start with a balanced chemical equation. So C6H5OH. What kind of reaction is this? Question mark, question mark. Go ahead, pause the video, try to write it out, try to balance it. Do that, and then push play. All right, so hopefully you already balanced this. It should be, so I have 6 carbons, so I'm going to put a 6 right here, and I have 6 hydrogens, so I'm going to put a 3. 6 times 2 is 12, plus 3 is 15, minus 1 is 14, divided by 2 is 7. Again, if you don't know how I did that so fast, then go ahead and watch the balancing combustion video. That is so awesome. I love ladybugs. See, told you I'm at the park. Okay, so again, start with what you know. Start with what's given. 3.81 moles of oxygen. That's what I'm given. And if moles of O2 is here, moles of O2 is going to go down here all the time, no matter what. And then where do I get this number from? Well, you have to ask yourself, what am I converting to? If you're converting to grams, if you're converting to liters, number 1 always goes next to mole. But this case, I don't want moles, or I don't want grams, I don't want liters. I want to go to moles of another substance. I want to cross that magical mole bridge. So I'm going to go to moles of CO2. And whenever I see moles above moles, I know I need to use those coefficients. So O2, the coefficient is 7, so 7 moles of O2. And then carbon dioxide, the coefficient is 6. And I would get my answer, and you would just do 3.81 times 6 divided by 7. So 3.81 times 6, enter, divided by 7. And that's it. So hopefully this helped you guys just see how to set up the questions. They're all the same. So every question in this practice here is exactly like this. Start with what's given, cross the mole bridge. And I'll make another video that goes through this challenge question, because it's not really challenging. It's just, taking it another step. And we'll also create the new mole map. So get excited.